Hey, and what is up? This is Unit 1, Lesson 1 of the Linux Deep Dive, and in this lesson we'll be covering the simple basics of Linux. If you're already familiar with Linux, I suggest that you go towards the end of this unit and maybe dive into Unit 2. Otherwise, I'd recommend you sit along and just enjoy the ride here. So basically what we're going to cover in this lesson is how Linux works at a high level, how to navigate around, and how to edit files, and just basically do basic things. In a couple of future lessons in this unit, we'll dive into more advanced tasks, just enough for you to be able to use Linux on a daily basis. Alright, so let's dive in. So the basic format of a Linux command. So if you open the command line in the terminal, the format will be, so the first part is going to be the name of the command. The second part is going to be your arguments. You may have 1, 2, 3, 4, 5 arguments. This is pretty arbitrary, the amount of arguments it requires. So for an example, the ls command lists the contents of the current directory you're working in. But you can it takes arguments too. For example, -lat/home/my folder. It takes 2 arguments there. That allows you to view it in listing format, list all the things, and the T is an additional argument we'll cover later. And the second argument we provided was /home/my folder, which means we can go and list the contents of that folder. Again, some commands may only take 1 argument, or they may only take a specific amount. And there's this thing called man pages. So if you're stuck, you can type in man, then the name of the command, and it'll pop up with this this manual thing for you to go and check out. And with that being said, let's dive into Linux file system structure. So everything is a file in Linux. You can even open folders themselves in text editors and edit the folders. So if you go to, slash is the root directory, or the lowest you can go. So like if you were to go in Windows and double click the C drive, right? That's basically what slash would be. It's the lowest you can go. And from there's a bunch of other folders in which everything's categorized. /etc would be basically a bunch of configuration files for your system. You can find things for your network lying around in there. You can find things for your time zone configuration in there. The device name might be in there. DNS might be in there. There's a bunch of cool stuff that we'll be configuring in this course that's in etc. /home, that's where your user directory will be created. So if you create a user, we'll just call him LOL. His folder will be /home/LOL. So if your My Documents folder will be /home/LOL/My Documents. /boot is where the Linux kernel is stored. That's basically where we go and have our system itself, like the real core files that allow the system to interface with the hardware. That's in /boot. That's where our boot manager is. In our case, we'll be learning how to use grub as a boot manager in this course, though there are some more funky ones like Lilo and syslinux that you can definitely read about and check out later on. /user and /var are other system folders that you can check out. They may have sample source code, they may have sample applications or configuration files. In bin and sbin, they stand for binaries. So that means bin is just binary storage, and sbin is system binary storage. So binaries are basically when you have things that you want to run. So like on Windows, you might see a .exe file. Linux, since everything is a file, that means any executable file that will run is a binary. Again, this is a very watered down explanation, but generally anything that is executable and it runs through what's called a compiler is a binary. And you can store that in bin or sbin, and it'll automatically execute at the terminal if you type the name of the command. Alright, so let's go and do a live demo of this stuff. So I'm currently running Gentoo Linux on this device using what's called i3 desktop. But here we go. So for example, screen fetch is a command at the Linux terminal, a very simple one that just gets system information. So now that we're here, let's go and do something called get our working directory. So basically I'm on my system and I don't know where the heck I am right now. So let's figure out where we are so we can go and do stuff. I'll type in pwd, print working directory, and it'll say I'm at /home/woot. Okay. So what if I want to list the contents of this working directory? I can do ls. But that's not printing out much information. I can do ls -l, and I can print out more information with file permissions, who owns the files, dates they were created, and so forth. I can do LA to list basically everything, including hidden files. Like, whoa, that's a lot of information. But what if we want to go and check out / and learn what's there? All right, so let's cd /. So change directory /. Okay, now if we ls, you'll notice that everything is organized into the folders that we mentioned. There's a few more. And that's because I actually wound up having to create a few of these folders for some of the applications I run on this laptop. But if we cd into boot, right, you'll notice that I can't view anything. That is because I'm as a user. So if I do su or super user into root. So by default, there's always a root user on a Linux installation. What root has is basically full permissions over the entire system, can edit anything, can view anything, can do anything with the system. So of course, naturally, it's common for people to either disable the root user or have a really complex password for it. And so you'll notice that I'm now in /boot. Oh, I don't have anything here. What's wrong? You'll notice that sometimes those directories don't get put in use. And by the way, if you do if I cd into boot, right, you can do cd ... to get out of the directory. So if we go to cd dev, you'll notice that this contains the devices that this laptop uses. Root has its own user directory in /root. Oh, it has a downloads folder. There's lib and lib64 for this device because on Gentoo you compile everything. So what compilation does, you know what? Let's show you that. So if we go and I need to teach you vim. So if we do vim, so cd ~/ that takes us to our home directory. In this case, it's /root. This is where root, and we do vim hello.c, and we'll do #include. So in Vim, this is a text editor that basically functions kind of like Notepad, or what's another well-known text editor that you might use. So there's Notepad, there's, well, not Microsoft Word, WordPad, something like that. But it's terminal based. So this allows you to alter things at the terminal. To use Vim, so you type in Vim, then the file name. In our case, we're doing hello.c. And to edit files, you'll notice, why can't I type? I'm tapping the keyboard and I'm not able to type. Something's wrong here. So what I do is I push the I key, and now I'm in insert mode. Now I can type it, now I can hammer away at the keyboard. But of course this is what's called a C program. So what we're going to want to do is write according to the C spec what we want it to do. In this case, we're going to have it print out something to the terminal. So we're going to want to do it. We're going to want to have it saying basically hello world. So what we need to do is we need to include the standard libraries for C. Hashtag include sedlib.h. Then every C program has a main routine or a main function. So int main void, because we're not taking any arguments for this. And we'll print f, so print with formatting. Hello Linux deep dive students \n, and we'll return 0. So basically, since this routine returns an integer, we're returning 0, saying it returned without error. And with that, we can go and exit insert mode by pushing the escape key. We can push the colon key, and that'll allow us to do a bunch of things with this file. So we can do W for write, WQ to write and quit, Q to quit and not save. Well, you'll need an exclamation point after the Q for that in this case. We've made changes. You can do question mark to search the file. So question mark and to write, and it highlights everything for us. If we want to run a Linux command within Vim, we type in exclamate. We can do colon exclamation mark ls, and notice how it lists out downloads. So you can use these things to speed up your workflow. But in our case, we'll just write and quit. And now, welcome to the C compiler. So there's this thing called GCC built into Linux, and it allows us to convert that simple .c program we wrote into this binary. And this is basically how Linux creates all these little applications you can run like ls, and allows us to use them all in such a fashion. So if we do gcc hello.c, okay, nothing happened, or did something happen? Let's do ls. Oh, wait a second, we have this thing called a.out. So how do we execute it from the terminal? We run /a.out, or the path to it. And hello, Linux Deep Dive students. Congratulations, you've not only written your first C program, but you've also learned how Linux effectively produces binaries. So what have we covered today? Well, in this lesson, we've covered the basics of how to navigate the file system. We've learned the basics of how Linux works, and you've learned how to edit files. In the next lesson, we'll cover the basics of what files to configure to get odds and ends done, and we'll dive into a little bit more programming and some configuration and how to do more bash syntax and learning more Linux commands, so we're better prepared for Unit 2.